Suppose you want to show that given premises do not entail a certain conclusion. How can you do that? Well, the basic strategy is to construct an FOL counterexample. And that means that you need to find an interpretation I on which the premises are true, but the conclusion is false. So for example, suppose you want to show that the sentence "there is an x such that gx" does not entail the sentence "there is an x such that fx and gx." We can show that this premise does not entail the given conclusion by finding an interpretation I on which the sentence "there is an x such that gx is true," but the second sentence "there is an x such that fx and gx" is false. Now, here's an example of such an interpretation. Let I be defined as follows. The domain of I includes only one object, namely the object A. The name D refers to A, and the predicate G includes A in its extension, but the predicate F doesn't include anything in its extension, so F does not apply to anything. So on this interpretation I, the sentence "there is an x such that gx is true," given that A satisfies the open formula gx, but the sentence "there is an x such that fx and gx is false," since no object satisfies the open formula fx and gx, given that no object satisfies the open formula fx. Okay, what have we done today? We have introduced a number of new concepts. We have discussed what FOL validities, contradictions, and contingent sentences are. And we have discussed when two FOL sentences are necessarily equivalent or jointly satisfiable. And we have discussed when given FOL sentences entail a conclusion. And then we have also discussed a number of proof strategies for establishing that a sentence is an FOL validity, contradiction, or contingent, or for showing that two sentences are necessarily equivalent or jointly satisfiable, and for showing that given premises do or do not entail a certain conclusion.